and the microbiome are the hottest fields right now in all of science. So all over the world, scientists are joining together in universities and countries all over the world to share the information. So this is a rapidly evolving field. Now, to get into the basics, or the most useful things that you need to know, you, I think, know this already, that we get one copy, half of our gene comes from our dad and half of it comes from our mom. As Roy Dittman mentioned in his talk, it's really, really important that both mom and dad have a healthy sperm and a healthy egg. And that's something that both of us feel tremendously passionate about, is that before a child is even conceived, that you do have a well-nourished body and a clean body. But if you don't know about your genes, it's going to be difficult to do that. Now, what we're going to talk about through the rest of the talk really are variants, or SNPs. SNP stands for single nucleotide polymorphism. And it just means that there was a change in the DNA, a mutation, if you want to call it that. But don't be afraid, because they're very common. These SNPs or variants are very, very common. Each of us has somewhere under 300 million of them. And this is why we're different. We're actually mostly alike. We're like 90% alike, 10% different, and that's what gives us our individual differences. But these SNPs are what make us unique. And they sometimes can be very dangerous, as you're about to see, but then also sometimes they're fixed. If you have a SNP, if you inherited a variation from one of your parents or both of your parents, then it can often be fixed, and usually with diet. Now, genes are really set at birth. What you get is forever. So if you have your genes tested, and you only have to have them tested once, you'll know what your genes are doing for the rest of your life. But they can be altered, and I just wanted to tell you the story of the bumblebee real quickly, because it's a perfect example. So in the beehive, all the bees are born with the same genes, and then some of the little bees are fed, some little female bees are fed royal jelly. So they grow up to be little princesses, and they're different. They have a longer body. They don't have any hair on their belly. They have a longer stinger, and if they sting anybody, their stinger doesn't. Usually the other bees, if they sting, they die. The queen bee doesn't. And so the bee that becomes the queen, she has to kill all the princesses, and then she's the winner, and then she's the strongest, best bee in the hive to reproduce. And so that's how we get a queen bee. Now, in the hive, there are different responsibilities. For example, some of the bees have to take care of the baby bees, and they're nursery bees. Some of the bees have to go off and gather nectar. And so the scientists did a really interesting study where they took these bees, the bunch of bees went off to gather nectar, and while they were gone, they took all the nursery bees out, and so there was no one to care for the babies. So when the nectar-gathering bees came back to the hive and saw that all the nursery bees were gone and there was no one there to care for the babies, some of them literally changed their genes and became nursery bees. And that happens more often than you think in nature. So genes can be altered when there's a need for that to happen. One of the most important things to remember, though, is that we are in charge of our genes. We decide which genes are going to be expressed or which genes are going to be silenced. And genes are just literally lying there, absolutely inert, waiting for some kind of a signal. But they do nothing until they get that signal, and it's up to you to signal them. And there's a lot of different things that we're doing that are signaling our genes and expressing them. There's some genes you want to be expressed, maybe the genes that give you a strong immune system, the genes that stop cancer from growing in your body. There are other genes, though, that you don't want to be expressed, like the genes that cause cancer, for example. So it's, we either talk about upregulating or expressing the genes or suppressing the genes. Now, very common SNPs or polymorphisms or mutants or variants, whichever word you want to use, you can have one for vitamin D and for the vitamin D receptor. This is a really, really important one to test for. MTHFR, which Roy mentioned a little bit about methylation. We'll go into that. B12 deficiency is an important one. Saturated fats, how do you deal with those? And if you are eating or doing the wrong things, the consequences can be very severe. You will develop the disease, you will, or you can fix the problem, and that's what's called an intervention or a solution. Other things you're going to test for that we're going to talk about today is your salt sensitivity. What about lactose, caffeine metabolism? I know everybody's into chocolate and coffee and everything, but it could be very dangerous for you if you don't know about this particular gene. And gluten, I mean, everybody thinks they're gluten sensitive, and more than 50% of the country now wants to be gluten-free. But is it really necessary? So we're going to talk about that. All kinds of vitamins can be tested to see, are you going to be deficient in B12, vitamin A? How do you do in that department? And then other nutrients like CoQ10, omega-3, 6, choline. There's a whole bunch of nutrients that you can test through your genes. Now, epigenetics is another important term to know when you're dabbling in this field, when you're stepping in, which please, I hope the nutritionists and everybody in here that's interested in health, that this talk today opens up your interest and that you really get into this field. And don't be afraid that it's complicated, because I know when I started learning about it, I felt like I was learning Greek or something. But if you just keep slowly but surely picking up pieces of the information, eventually it all weaves together, and eventually you can go deeper into an understanding of it. I hope you're not sitting there thinking, oh my gosh, this sounds really complicated, because it is and it isn't. But an important term to know is epigenetics. Epigenetics means above the genes. So there the genes are lying in, wait for some kind of signal. Then the epigenetics is what's signaling them. So that's all that term means. But you can take the little boy in the picture who's in Nigeria, growing up in a very different environment than a modern kid today who might be in his somewhat sterile apartment playing with his TV and games and, games on TV all the time. And so that's a very different lifestyle. His epigenetics, what's expressing their genes, are very different. And so what are examples of epigenetics? How we eat, the amount of stress, which is huge. Sleep, are we getting enough sleep? Then again, where your genes allow you to get enough sleep. Vitamin D and other vitamins, the climate that you live in, and the thoughts, even your thoughts, as Bruce Lipton is so great about talking about. Another main key thing to remember is you're in control. You completely control these genes.